Okay everyone, today we're going to continue on with the exponent laws or the exponent rules. We're going to look at three different rules which are called the power rules. So let's get right to it. Let's talk about the power rule. So you know how I love showing you things for you to discover rather than just giving you the power rule. So let's discover it here. If you had something like 4 squared cubed. Okay, let's see, we needed to figure that out. Well, there's two things you could do. The first thing you could do, or one way you could do this, I suppose, is you could think about this first, that cubed. What does that cubed mean? That means that whatever is inside the brackets, you need to multiply by itself 3 times. So it would be like 4 squared times another 4 squared times another 4 squared, right? Because we're taking the base, which is 4 squared, and we're cubing it. We're multiplying the base, 4 squared, by itself 3 times. All right, well, what's 4 squared? 4 squared is the same as 4 times 4. And then we have times, this times right here. I'll put times. Then we have this 4 squared, which is 4 times 4. Then we have this times, so I'll put times again. And we have this 4 squared, which is 4 times 4. So we end up with 4 times 4 times 4 times 4 times 4 times 4. Did I say the right number? I think I did. So how many 4s is that? That's 6. In exponential form, it's 4 to the 6th power. All right. Let's say that you didn't want to do all this middle part, because you probably don't want to do all that middle part. How could you have gone straight from this question here to the answer over here? See what you could do with the exponents? You just multiply them together and you'll get the answer. But look, let's do this a different way too. What if I dealt with this first? What would that mean? That would mean I'm going to square 4 to start. Well, 4 squared, that means 4 times 4. And then that's in brackets, right? All I've done is expand the 4 squared to get 4 times 4, and it's still cubed. Okay, again, what does it mean when we cube something? It means we take the base, which is 4 times 4, and we multiply it by itself 3 times. So we have to go 4 times 4 once, 4 times 4 a second times, and 4 times 4 a third time. Which we end up with is 4 times 4 times 4 times 4 times 4 times 4. Hey, we get the same thing. We get 4 to the 6th power again. So those are two different ways to show you that when you have 4 squared cubed, it's equal to 4 to the 6th. And again, how do we get that 4 to 6? We actually only had to do 2 times 3. All you have to do this time is multiply the exponents together. So the power rule says to raise a power to a power, that's what this is, a power raised to another power, the power of 2 raised to the power of 3, a power raised to a power, you just multiply the exponents. So how you could write that mathematically is you could say a to the m raised to the n is equal to, well, the base stays the same, right? It was 4 here, it was 4 there, it's still going to be a. But now to get your exponent, you're going to go m times n, or if you want, times that way. It doesn't matter which way you put it. Okay? So let's try a few questions here. First one, we have 3 to the 4th power raised to the 5th power. Oh, power of a power. Keep the base the same, multiply the exponents, 3 to the 20th power is your answer. And again, in many of the questions today, you're just going to be leaving it in exponential form. If you were asked to put it in standard form, you take your calculator and figure out what 3 to the 20th power is. Although that's so big, it would barely fit in your calculator probably. Okay, next one. You have -7 all in brackets, so that's the base, raised to the 4th power, raised to the 4th power. So keep the base the same, which is -7, and 4 times 4 is 16. Okay, if I do that, is it right? No, it's not right. You see how the base was all of this, -7? If I write it like this, I've just turned the base into just the 7. The whole base is -7, just like it was up there. Base was -7, base is -7. Hey, I have a question for you. Is this answer, when we do -7 to the 16th power, is it going to be positive or negative? We're doing a -7 times -7 times -7 times -7 16 times. That's an even number. Well, if you multiply a negative by itself 16 times, or if you multiply 16 negatives together, I suppose you could say, you're going to get a positive. So you know what an even simpler way you could write for this answer? There's nothing wrong with this, but an even simpler way to write this is you could just write that. How come? Because we already know for sure that this must be positive, so then we can just leave the negative out, and we know this would actually be the answer. Okay, a little advance there. Okay, next question. Now, the base in this question is just 2 to the 8th, right? So we have 2 to the 8th cubed. We also have this negative out front. Remember, a negative out front is kind of like a multiplication step. So this is multiplication, and this 3 here is an exponent. You got to do the exponent first. So we have 2 to the 8th to the 3rd power. We're going to use our power rule, which we just learned. So we have 2 to the 8 times 3, and we still have the negative. So it's 2 to the 24th, and we still have the negative up front. Now, can I get rid of the negative this time? Because look, it's even again. The exponent's even, so can I get rid of the negative? No. Why not? Because this time the base is not the negative 2. If we were going to still have brackets, the 2 would go here around the 2, not around the negative 2. So in other words, this negative here is a slap it on at the end negative. This is like 2 raised to the 24th power and then slapping on a negative. So you have to keep this answer negative. I'm just going to go back to this. This is my answer. Okay, 5 to the 5th power raised to the 0 power. Okay, well, there's 2 ways to look at this. One is anything raised to the 0 power is 1. So we know right away the answer must be 1. The other way you could do this is you could use the product rule. You could say I have a power raised to another power, so I multiply them. 5 times 0. Well, anything times 0 is just equal to 0. And 5 to the 0 power, well, that equals 1. Anything to the 0 power is 1. So either way you do it, you get 1. It is faster, of course, if you just realize that all of this is raised to the 0 power, so the final answer has to be 1. Okay, little bonus question here. I want you to take this 27 to the 5th power, and I want you to write the same amount, but with a base of 3. How are you going to do that? Well, what you want to do is you want to change the 27 into 3 to something. You want to figure out which exponent would go right here, and then we still have it to the 5th power. So 3 to the what power equals 27? Well, 3 times 3 is 9, and 9 times 3 is 27. So it took 3. 3 to the 3rd power equals 27. So all we did is took this 27 right here, and we rewrote it as 3 to the 3rd, which is fine. 3 to the 3rd is 27. Our 5, the power 5, is still right here. Now look, you have 3 cubed to the 5th power, a power of a power. What can you do with your exponents? Multiply them together. So you get 3 to the 15. So in other words, 27 to the 5th power is equal to 3 to the 15th power. We like having that base as small as possible often. Okay, our next rule for today. Raising a product to a power. So let's look at an example. If you're doing something like this, 3 times 4, that's a product. A product is when you're multiplying things together. So that's a product, but now we're going to raise that product to a power. Let's raise it to the 2nd power, so we're squaring it. Okay, what does that mean? Well, we're squaring the base, and the base is 3 times 4. So we need to multiply the base times itself 2 times. So it's 3 times 4 times 3 times 4. Now, when you multiply a whole bunch of things, you can write them in any order you want. So I'm going to write it this way. Instead of going 3 times 4 times 3 times 4, I'm going to go 3 times 3 times 4 times 4. Now, why did we do that? Because look, 3 times 3 is the same as 3 squared times 4 times 4 is the same as 4 squared. Okay, same old question. How could we have gone straight from this question here to this answer here? See what you do? You just apply the 2 to both numbers, 3 squared and 4 squared. There was an old legendary teacher at our school named Miss Massoud, and she used to call this spreading the love. You're spreading the love of the 2. So it's often what I refer to it as. This is a spreading the love question. Okay, so what's this look like? To raise a product to a power, raise each factor to that power. So the 2 factors in this case are 3 and 4. You're just raising them both to the 2nd power. The way you'd write that mathematically, AB, if I have nothing between 2 letters, you know what that means? It means times. If you want to put a dot in between, that's fine. So AB, or A times B if you want, raised to the nth power is equal to A to the nth power times B to the nth power. And again, you don't need to put this dot here. You could just have A to the n, B to the n. Okay, let's try a few of those. So here you go. You have your multiplication statement, and you're going to spread the love of this power here. So you're going to end up with 2 squared times 3 squared. Okay, that might be where they want you to stop today. They might want you to leave it in exponential form, in which case you're done. Or maybe they want you to actually get the answer, in which case you'd go 2 squared, well that's 2 times 2, which is 4, and 3 squared, 3 times 3 is 9, and then multiply them together and you get 36. Do you see another way we could have gotten 36 if we'd gone back up here? Could have followed bedmass and done the exponent, the brackets first. 2 times 3 is 6, and then the exponent next. 6 squared is 36, so you still get 36. But to tell the truth, you're usually going to have letters involved. We're going to have lots of algebra this year with letters in it, so you're usually going to have letters involved when you're going to use this rule. So you don't have the option here of multiplying 5 times m to start because you don't know how much m is. So the only way you can do this question is to spread the love. Now remember, this is 5 times m. There's two factors here. So you're going to spread the love of that n to the 5 and also to the m. What's 5 to the nth power? It's 5 to the nth power. There's nothing else you can do. What's m to the nth power? It's m to the nth power. There's nothing else you can do, and you're done. If you want to put a little dot in between, fine, but try to get in the habit of not doing that. Okay, next one. Okay, now, you only have two factors here. You have an a squared, and you have a b cubed. So what you have to do is you have to spread the love of that 4 to the a squared and also to the b cubed. Wait a minute, how's that going to work? That means you're going to have a squared to the 4th power, and you're going to have b cubed to the 4th power. Well, wait a minute. Do you see what rule you can use now? You have a power raised to another power. We're going to use the first rule we just learned today. What are you going to do with those two exponents, the 2 and the 4? You're going to multiply them and get a to the 8th. What are you going to do with these two exponents? You're going to multiply them and get b to the 12th. And there's nothing else you can do. You're done. Okay, now we're going to raise a quotient to a power. You know what a quotient is? A quotient is when you divide. So for example, let's say we had 2 over 5, 2 divided by 5, or 2/5 if you want, and we're raising it to the 3rd power. Okay, again, what does this mean, this cubed here? It means whatever the base is, and in this case the base is 2/5, we're going to multiply it by itself 3 times. 2/5 times 2/5 times 2/5. Well, wait a minute. When you multiply, you just multiply the top numbers together, 2 times 2 times 2, and multiply the bottom numbers together, 5 times 5 times 5. Well, 2 times 2 times 2 is the same as 2 cubed, and 5 times 5 times 5 is the same as 5 cubed. You know what I'm going to ask you right now. How could you go straight from here to here? You know what you're going to do again? It's another spreading the love question. Spread the love of that 3 to the 2. Spread the love of that 3 to the 5. Spread the love all around, people. Okay, so the rule is to raise a quotient to a power, raise the numerator, that's the top number, to that certain power, and raise the denominator, the bottom number, to the same power. Mathematically, a over b raised to the n power is going to be equal to a raised to the n power and then b raised to the n power. Okay, let's try a few of those. Okay, that's ridiculous. The first question here is exactly the one I just did. What a fail. Spread the love of the 3 to the 2 and the 5. You get 2 cubed, you get 5 cubed. Now, of course, what I didn't do up here, and you could do, is you could also figure out what this answer is. 2 cubed, that's 2 times 2 times 2, which is 8. 5 cubed, that's 5 times 5 times 5, which is 125. Let's pretend they were looking for this answer. Okay, next one. You're going to spread the love of this n to the a cubed and also to the b squared. So you have a cubed raised to the nth power, and you also have b squared raised to the nth power. See what you can do now? Power rule. You have a power raised to another power. So you're just going to multiply them. Now, do you know what 3 times n is? It's really basic. 3 times n is 3n. So you have a to the 3n. And then the bottom you have b to the, what's 2 times n? 2n. That's your answer. There's nothing else you can do. Okay, this question, there's a couple ways you could do this. So one way you could do this is you could spread the love of this 4. You could spread it to the 5 and also to the 2. So you have negative 4 to the 5th to the 4th, and you have negative 4 squared to the 4th. We've spread the love of the 4 to both of the numerator and the denominator. Okay, now we need to multiply our powers. So those two are going to be multiplied together, and those two are going to be multiplied together. So you get negative 4 in brackets, don't lose the brackets, to the 5 times 4, which is 20, and negative 4 to the 2 times 4, which is 8. Good. All done? Well, actually, there's another rule you could use here. What was our rule we learned last day when you had the same base, negative 4, and you were dividing? What can you do to the exponents? You can subtract them, not divide, subtract. So you get negative 4 to the 20 minus 8, which is negative 4 to the 12th power. And there you go. You could circle that and make it your answer. But do you see one more thing you could do? You could also think about whether this answer is going to be positive or negative. You have negative 4 times negative 4 times negative 4 12 times. 12 negatives make a positive. So you actually know that your answer is going to be 4 to the 12th. That would be the best answer of all. All right, I said there was another way you could have done this. You could have started way back here and done the quotient rule right there. So we're dividing here and we have the same base. So what could you do? You could subtract those exponents, the 5 and the 2. So you'd now have negative 4 to the 3rd power, and it's still to the 4th power. And then you could use your power rule and you could multiply the 3 and the 4 together and get your 12. So you actually end up with the same answer either way. Okay, that'll often be the case where there's more than one way to do this. Okay, next one. Watch very carefully, people. Don't write anything for a second. Here's what people do all the time. All right, I know how to do this question. I'm going to spread the love here and here, so I get 3 to the 0 squared plus 2 cubed squared. Look good so far? No. Wrong. Please. I've taught you the most common mistake in math. This might be the second most common mistake. You cannot spread the love when it is an addition question, and you cannot spread the love when it's a subtraction question. You can spread the love when it is a quotient, when it's a division question, and you can spread the love when it is a multiplication question. And that's it. No spreading the love on this question here. You're not allowed. So what can you do? You just got to work the whole thing out. So what you would do, follow BEDMAS here. I'd first of all look in my brackets. In the brackets, I would look at the exponents, so I'm going to do those first. 3 to the 0 power. Anything to the 0 power is 1 plus 2 cubed. That's 2 times 2 times 2. We've done that a bunch of times. That's 8. It's still squared. Still simplify the brackets. 1 plus 8 is 9. Don't do this. You still can't do that. You can't spread the love if it's an addition question, so don't do that. 1 plus 8 is 9. And it's still squared, and 9 squared is 9 times 9, which is 81. That's your answer. There's no exponent rules you can use in this case. And if this was a subtraction question, I would say exactly the same thing. There's no exponent rules you can use. Only multiplication and division. All right, now these last two, if we can compare them to each other, it kind of looks like, well, they must be exactly the same thing. Look, I multiply the 2 and the 3 together because it's power of a power, and I get negative 1 to the 6. And I multiply the 3 and the 2 together because it's power of a power, and I get negative 1 to the 6 are exactly the same. Believe it or not, this is not true. Why not? Because if you look at this one, let's look at this one first over here. We have some amount and we're squaring it. So look at this amount that's highlighted as negative and we're squaring it. When you square a negative, what kind of answer are you going to get? You're going to get a positive answer. This must be positive. Okay, now let's look at this one. In this one, we have this certain amount, which is negative, and we're raising it to the 3rd power. So we're multiplying a negative times a negative times a negative. When you multiply negative by itself 3 times, it must be negative. So we know the answers are going to be different already. So in both cases, both these questions, we're going to go 2 times 3 because of our power of a power and get 1 to the 6. But in this case, it's going to be negative, and in this case, it's going to be positive. We could simplify it more. What's 1 to the 6? That's 1 times 1 times 1 times 1 times 1 times 1. Well, that equals 1. So this question is going to be negative 1, and this question is going to be positive 1. Tricky. I've definitely, put a very difficult question here at the end. If that one confuses you, don't worry about it too much. But hopefully the rest of it all makes sense. Okay, everyone, I'm here for you. If you have any questions with this last bit or anything else, just let me know and I can help. See ya. Bye.